Picture this. You're watching a movie and a pilot radios the tower. We're cruising at 450 knots. Or you're reading a ship's log and it says wind speed 25 knots. And you probably wonder, why don't they just say miles per hour? Why do pilots and sailors use this weird, old-fashioned unit that no one else seems to care about? The answer isn't just tradition, it's actually genius, because knots aren't really about speed at all. They're about location. Let's start with the word itself. A knot is 1 nautical mile per hour. But what's a nautical mile? And why is it different from a regular mile? Here's where it gets interesting. A regular mile, the kind you see on road signs, is based on land. It was originally defined by Roman soldiers pacing out 1,000 steps. Over time, it got standardized to exactly 5,280 feet, but that number is pretty arbitrary. It works fine for measuring roads and fields, but it completely falls apart when you're trying to navigate across an ocean or through the sky. Because when you're out at sea or flying over a continent, you're not thinking about roads. You're thinking about the entire planet. And that changes everything. The Earth is a sphere. To navigate it, sailors and pilots use a grid system. You've probably seen it. Lines of latitude run horizontally around the globe, and lines of longitude run vertically from pole to pole. These lines are measured in degrees. There are 360 degrees all the way around the Earth. Now here's the key. Each degree can be divided into 60 smaller units called minutes. Not time minutes, angular minutes. If you travel along the surface of the Earth and move 1 minute of latitude, you've traveled exactly 1 nautical mile. That's the whole point. 1 minute of latitude equals 1 nautical mile. This means that a nautical mile isn't some random measurement pulled out of thin air. It's directly tied to the geometry of the planet. It's a distance that actually means something when you're navigating across oceans or continents. So when a ship's captain says, we're 300 nautical miles from port, they can instantly plot that distance on a map using the latitude and longitude grid. The math lines up perfectly. No conversions, no confusion. Land miles don't do that. If you tried to navigate the open ocean using regular miles, you'd have to constantly convert between miles and degrees and minutes. It would be messy and slow. And in the middle of a storm or in the cockpit of a plane traveling hundreds of miles per hour, messy and slow can be dangerous. But wait, where does the word knot come from? This part is surprisingly physical. Centuries ago, sailors didn't have GPS or speedometers. They had to measure their speed using a tool called a chip log. It was basically a wooden board tied to a long rope. The rope had knots tied into it at regular intervals, usually every 47 feet. The sailor would throw the board overboard, and as the ship moved forward, the rope would unspool. Someone would count how many knots passed through their hands in a specific amount of time, usually measured with a 30-second sandglass. The faster the ship, the more knots slipped through. So when a sailor said the ship was moving at 5 knots, they meant 5 knots of rope went out in 30 seconds. That corresponded to roughly 5 nautical miles per hour. The term stuck. And even today, pilots and captains still say knots, not knots per hour, because the word itself already means per hour. Here's where it all comes together. Nautical miles and knots aren't just about tradition. They make navigation faster, simpler, and more accurate. When you're flying over the Atlantic or sailing across the Pacific, your instruments, your charts, and your measurements are all speaking the same language. 1 minute of latitude, 1 nautical mile, 1 knot per hour. Everything lines up. On land, miles per hour work fine. But the moment you leave the pavement and enter the three-dimensional world of air and sea, knots become the most logical choice. So the next time you hear a pilot say, cruising at 400 knots, you'll know they're not being old-fashioned, they're being efficient. They're using a unit of measurement designed specifically for navigating the curved surface of a spinning planet. And honestly, that's pretty brilliant.